Okay. 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 Martin. Okay. Good morning to you, all the participants, students, and other participants who have come for the second day of this particular JNTH curriculum. This is the second day. First day, I have explained in detail, briefly also. Hello? Hello? బాగానే ఉందా వాల్యూము?
Yes, sir. Clearly on, sir. Voice clearly on, sir.
Okay, I'll stop then. I'll stop. Okay. Okay, okay. 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 Hello. Good morning to you.
Sir, very good morning, sir.
Good morning to you, students, and also the distinguished participants. For the next 1 hour, I'm going to take up this second day class. And as you know, yesterday I talked briefly about the radar. What is its contribution to the present modern day society? You know, from what I have talked there,
This
radar
conference
has,
will now be recorded.
you have been told that the modern society today will not be able to sustain without radar. All the transport, sea transport of goods, 80% or more than that, goods transport, commerce, all this taking place to the ships, and these ships have to be equipped with radar if they had to move in high seas during the snowing, raining, haze, clouds, things like that without collision. Similarly, we also know that the flights that are taking place across the whole world need the radar for the aircrafts, commercial aircrafts, to land on the runways and take off from the runways. Hundreds of these aircrafts in each airport will have to operate. So radar is a must in these circumstances. Third important civilian use of the radar is the weather prediction. In the case of cyclones, tornadoes, and also storms, people have to be warned so that they can vacate their places and save their lives. So radar has become very, very important. In future also, when we are talking about the vehicles, autonomous vehicles, driverless vehicles, robotic control traffic, in future, radar is a must. The biggest advantage of radar is, unlike our vision or unlike any other means like IR, laser, it will penetrate and will be able to see in darkness, in rain, in haze, in cloudy weather, when there is a lot of pollution, smoke, things like that. So this is the biggest advantage of radar. There is no other device which will suffice our requirement to see in these particular situations. Now today we are going to talk about only the principles, from the fundamentals, how this radar is going to work, how it is going to work. As you know that our JNTUH has made 5 units for 5 units, and each unit has got a distinct way of presenting. First 2 units will be on the fundamentals of the pulse radar and the CW radars. Third unit will be on the MTI radar, moving target indicator, very essential. Without that, we will not be able to use this radar. Why it is so, we will come to know in course of time. Fourth is the chapter, fourth unit consists of the tracking radar. These tracking radars are not meant for civilian use, but they are used in the military. It is used only in military. The military is supposed to protect our borders. The military armed forces had to fight in air wars, land wars, sea wars, and radar is going to be the only device which can see through and give the information. And also I talked about the job opportunities of people who learn this radar subject. What we are going to learn in next few classes are only fundamentals. Based on the fundamentals, we are going to now see that as you progress, more and more important things are coming through. Yesterday I mentioned about the synthetic aperture radar, which was able to tell the troops, Chinese troops, which are there in Ladakh. These radars are mounted on satellites. They are called synthetic aperture radars. In times of clouds, also they can see the installations that our enemy has put. So the photographs also you might have seen in recent the newspapers. So the radar has become a very, very essential part of our life. Like a mobile has become a personal device for us today, radar has become a device and equipment which is very essential for our modern civilization, for us to sustain with our business and commerce in the world. So now this is the syllabus that is given by the JNTU. We will talk about the basics of radar, then maximum unambiguous range, simple form of radar equation, radar block diagram and operation, radar frequencies and applications, prediction of range performance, minimum detectable signal, receiver noise, modified radar range equation, and some problems. Then when we talk about the radar equation, we talk about the SNR, that is the signal to noise ratio, envelope detector, false alarm time and probability, integration of radar pulses, radar cross section of targets. Then also talk about something about the transmitter power, PRF and range ambiguity, system losses, illustrative problems. So this is the this is the subject, this is the details, detailed functionality of the particular of unit 1, where we will cover this. So yesterday there was a question by one of the students that if he reads this particular subject, will he be able to design a radar? Then I will ask one question to that particular student. You will be you have been taught about communication systems, then the mobile communication systems. If you know the principles, will you be able to make a mobile phone? So there is a lot of difference between knowing the principle and making a hardware. A mobile may cost, maybe the costliest one may cost 80 to 90,000 rupees. But whereas a normal radar will cost not less than 300 to 400 crores, which means that you can see the complexity of the system, that is number of systems that are being used. So this is only a platform, basic platform, a stepping stone for you to understand. And when you go further, if you want to take specialized radar courses, which are available in other universities and also Usmania University, then you will be taught how to design, how to make, how to develop, what are the intricacies, what are the things, tips you have to do. So it is basically a science in which the equipment takes not only time, not only complexity, it takes also a lot of money and effort. In order to make a radar to your specification, it may take 3 to 4 years with a large amount of engineers helping us. Okay, then what does it mean? Radar is where from this name has come. The name radar has come. It's from the functionality of the radar. It is called the radio detection and ranging. That is, RA is taken from the first word, D is taken from the second word, A is taken from the third word, and R is taken from the last word. So this is the acronym. Acronym you can always also call is the small form of radio detection and ranging, abbreviated form of radio detection and ranging. Okay, so let us remember this. Many a times I have seen students not answering what is the acronym, is what radar stands for. It is nothing but radio detection and ranging. Yesterday I told you also that military, it started with 60% of the equipment is used radar, but today modern sophisticated equipment, all missiles, all equipment, all tanks, all aircraft, all ships use this radar, and the use of this radar has already crossed more than 85% of this equipment. So therefore, it is essential that we should learn something basics of this radar. What is this radar? It is basically a very simple concept that all of us know. Let us say that, of course, now you can't go to a hill resort in this COVID days, but earlier people have gone to hilly areas like Ooty and other places. When you are a small child, boy or girl, when you stand in between the hills and say, hello, if you call like this, after some time, you get the reverberation. It is called the echo of your sound. So again, you will hear hello in a smaller, smaller voice. So that means what is that? That particular sound waves which you have generated has gone and hit a hill. They have reflected those things. So those things you are able to hear in the form of echo. Same thing applies to radar also. Same thing applies to radar. There are this radar is works on what is called the electromagnetic frequencies, whereas sound works from up to 22 kilohertz, but whereas radar works from starting from 10 megahertz to almost 30 gigahertz. 30 gigahertz. Different types of radars are used for different purposes. So now it's a radar. So So basically, it has got four very, very main functions. What it does is, it detects the presence of reflective objects. Suppose I have got a source, transmitter source. I start emanating that RF energy. So once that RF energy or the electromagnetic energy goes into space, in space there may be a lot of obstacles. Let us say one aircraft is coming from somewhere. So this RF energy goes there, hits that particular aircraft. The aircraft is made of certain alloys of aluminum, strong alloys, material alloys of aluminum. They are called the dielectric materials. These dielectric material, any dielectric, even wood is a dielectric material. Your body also is a dielectric material. Anything is which is abstract and it has got a sub molecules and atom. It's called the dielectric material. In the different, it has got different characteristics. So this particular echo refractions from the aircraft is sent back in the same way it has come. So if you get back these signals that you get back will be very, very, very low. Their power will be very, very, very low. If we have a means of electronics amplifiers, very sensitive amplifiers, the order of power you will be getting will be in micro volts. So you need to amplify the intensity of the signal. So those days, slowly people started making amplifiers, cluster amplifiers, then solid state amplifiers, things like that came, magnetrons came into picture. So many things were made. So those things are amplify the signal. When they amplify the signal, you can present that particular signal on a display. So we have got laptop here. Laptop, we are able to see the letters there. In a similar way, you will be able to see the reflection. Suppose you send a pulse. Pulse is, it will be there for a short moment and it will go away. That means it collapses. So that particular pulse you sent into the air. So let us say for a t is equal to 1, the 0, the level is, let us say, you are sending 100 kilowatts. And after 10 microseconds, you are switching off that particular transmitter. So this particular 10 microsecond pulse, micro means 10 to the power of minus 6, 10 to the power of minus 6 seconds. So very small, you cannot see with your eyes, only with a oscilloscope you will be able to see. So when it goes into the air, if there is any object, let us say there is an helicopter, let us say aircraft, let us say drone, whatever is there, it will reflect. It will, same pulse, it will reflect with a very small amplitude and intensity. That's what I told. Once you have got the amplification, you can show it on a
This conference will now be recorded.
pulse. It shows that there is a object in front of this particular transmitter. So this is very useful. Suppose a vehicle is going very fast, 200 kilometers per hour, and if in front of you there is again one more vehicle going, if you are having a autonomous vehicle, if that particular vehicle is not able to see the vehicle because the robot doesn't have eyes, and moreover it may be dark, maybe the car may be traveling in night. So when it sends a pulse, it gets back. That means you know that there is a presence. There is a presence of it shows that there is a object in front of you. It may be a vehicle, it may be anybody else. Even radars detects even the persons also, movement of the persons. So therefore, it detects the presence of reflective object. I will tell you what it uses. in course of time. Just to finding out, detecting the target, it is called the target. Anything, object, any object, it may be an aircraft, a ship, or tank, or person, or a vehicle. All these are called targets. So from now onwards, we will use the object. It's not a technical term. We will use it as a target. Target. Whenever there is a target, there is a reflection. That means that we know that in front or backwards or any other angle, there is an object. That is why it detects the presence of reflective object. Second is very, very important thing. It gives the range of the reflective object. How far
sir?
it is there. Hello?
Sir, sir,
yes.
can you show with some figure, sir? Figure. Any figure is there?
As I go, I will show you. As I go, I will show you. Okay. As I proceed, I have got the figures. So, since it's the long drawn 30 hours cross, I will slowly build up the subject. So, it gives the range of the reflective object also. That means how far it is. Is it in 10 centimeters, 20 centimeters, or 10 meters, or 10 kilometers, 100 kilometers? That also it gives the range. Then, one more advantage of this is in what direction it is there. Is it there in the north direction, or 30 degrees from north direction, or 40 degrees from north direction, or 320 degrees from north line? It gives the angle that is called the azimuth angle. It also gives what is the elevation. From the elevation, you can get the height also. So therefore, these three are very, very important, and also it gives the velocity of the moving object. It also gives the velocity of the moving. How it gives? Very simple. We will talk to you as I develop the subject. And what are these reflective objects, dielectric objects? It can be an aircraft, it can be a ship, it can be a missile, it can be a motor vehicle, and as I told you, we will call these things, all objects, as targets in our technical terms. So in fact, everything it reflects. Everything it reflects. Any electromagnetic energy, when it is obstructed, it reflects. So what are the advantages of radar? Why can't we see with our visual eyes? Radar advantage is that, as I told you, you can see an object in front of you if there is a sunlight, and you can also see you cannot accurately tell how far the object is there. If there is a tree within 100 meters, because God has given two eyes, by locating the tree by triangulation, you can say how much is the distance. But if it is a distance of 10 kilometers, you will not be able to see the object. You will not be able, even if you see, you cannot tell the range of that particular thing. So, but a radar which is here, it comes to our rescue. It tells us about whether the aircraft is 100 kilometers, 200 kilometers, or missile is 500 kilometers. It will be able to tell. That's the advantage of the radar. So, radar detects and locates target hundreds of kilometers away. Radar detects targets in darkness, rain, snow, hail, smoke, etc., where human eye fails. It is not only human eyes. There is nothing, no science or no technique to tell us about this in darkness. Even when any one of them happens, whether there is in front of you or backward, sideways, there is an object. So human eye fails or any other device fails. This is the advantage. That is why radar has become very, 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 very famous. Even medical field also, when they inject the dye, so very high frequency radar transmitters emanate. The reflections will tell whether there is the photograph of that will tell whether there is a cancer tumor in your body, things like that. Second thing, that unfortunately Radar, okay, it gives detection, it gives all other that four uh, functionality, but the disadvantage of radar is resolution is poor compared to eye. So if you ask the radar to find out, tell us whether it is A or B or C or D or H, it cannot do. Our eye has got a larger resolution. God has given two eyes to locate the position. For location, for finding out the range, we need always two sensors location. So that is the resolution of the eye is very high, which cannot be seen by the which cannot give by the radar. But today radar, synthetic aperture radar are giving us a resolution of almost 1 centimeter or less than 1 centimeters. So that is how we are able to locate the objects from a distances of thousands of kilometers from when the radar is mounted on a satellite. So some people say infrared. Infrared is nothing but again extension of frequencies of electromagnetic waves. When you are talking about 10 to the power of 14, 10 to the power of 15, 16, to infrared, near infrared, infrared is used in space vehicles where there is no atmosphere, there is no oxygen there. There is a totally space is vacuum. So infrared is used there. Similarly, infrared is used in air-to-air missiles, where the distances between the missiles are hardly 2 to 3 kilometers. So, but advantage of infrared is because they are having huge frequencies, their resolution is very good, very good. So you must have also seen infrared goggles being worn by our soldiers in night. So if what happens is that there, since the frequencies are very small, the resolution will be good and you will be able to see the movement of persons, the figure of the person, the figure of the vehicle. Especially this is very important when you are making a patrolling or when you are guarding a military installation, whether any enemy is intruding into your things. So infrared is used. Okay. So here is the principle here. So you have got a transmitter here. Then this is the wave that you have transmitted, or wave. When it gets reflected, the reflections are very small. It will be detected by the receiver here. This is the principle of the radar. Principle is very simple. Everybody knows. I told you, when you sound also reflects things like that. So what is the principle of radar? Coming back, EM energy radiation to space. When a metallic or dielectric object, aircraft or ship comes in its path, a portion of energy is reflected. It as the RF energy expands, not all energy will be impinging on the object. Only a portion. That is why the reflected echo will be very small. The reflected energy is called the echo. Echo indicates presence of target. If there is no echo, there is no target. Echo is detected in a high sensitivity receiver called a radar receiver. Echo is amplified and shown visually on a radar display. So let us see. These are all the some of the photographs of the radar. Yesterday also I have shown. This is it is somewhere located near the New York, and it is supposed to tell the people who are operating this particular radar. It is a phased array radar, is electronic scanning radar. Even thousands of 10,000, 20,000, 12,000, 15,000 kilometers away, if Russians those days, when you were maybe a small child, there was a big rivalry between Americans and Russians. So the Russians, when any Russian missile is launched with a nuclear bomb, the US wants to know so that they can also get ready to intercept that missile in air and destroy that missile. So at least 20 to 30 minutes of travel time, if you can get, because electromagnetic energy travels at a very fast, 3 into 10 to the power of 8 meters per second. So you will get the information much faster before the missile with the atomic load comes onto the territory. So again, this is one of the radars which is done by the Raytheon. They're all phased array radars, and here you have got a globe here issue. This is actually the radome. Somebody asked yesterday radome about this radar. This is meant for protecting this radar from atmosphere. If there is a heavy wind and things like that, radar antenna should not get dismantled or get destroyed, or something happens to the mechanical structure there. So therefore, they put a that is called the radome. This is called the radome, the protection. That's a mechanical protection for the radar. Radars also are used in ships also. You see so many radars are there. Why so many radars are there? You will come to know. You will come to know in course of time. Single radar cannot give the information. Again, this particular radar is called secondary surveillance radar. This radar, peculiarity of this radar is it will not only tell it is whether an object is presence of an object on an aircraft. It will also tell you this particular aircraft that is trying to come land into your airport is belongs to which company. Is it Air India, or is it a TWA, or is it Netherlands, or is it a BOAC or South Arabian? All this information is required for the operator who is sitting inside what is called the ATC room. That is air traffic control rooms. Before him, he will be seeing more than 300 to 400 aircrafts flying on the air. So he has to control all of those things. Secondly, there is again an aircraft which is called the EW aircraft, and here this is called the radome. We will go into the details at a later time. Okay, this is also a magnified picture of the Cobra Dine. This is called the Cobra Dine radar, which is there somewhere in New York. So these radars are segregated into three types. One is called the early warning radar. Suppose we are protecting, let us say, our enemy. We have many of these radars across our western border and the eastern border. This particular radar is able to detect if our enemy has launched a missile or a deep penetrating aircraft is coming to release bombs in our territory. So then this has got a range of 400 to 500 kilometers, 400 to 500 kilometers. So it gives early warning for our troops to be ready. There are two ways of intercepting a missile or an aircraft. If you have a interception of an aircraft or missile, you have to fire anti-missile missiles onto the incoming missile. If it is an aircraft, you can fire a missile, or you can ask our aircrafts to go into the air and start fighting. So that means they can start fighting like any other gunfight. It is called the gunfight. It is called the dogfight. It is called the dogfight. So in air, they start operating all their guns around the aircraft, and they will shoot down. It's called the dogfight. So these are the two things that you can see. And again, this is a medium range radar. That is, this particular radar has got a lesser range compared to the early warning radar. In the early warning radar, we don't get the height information, that is the elevation. But here you get the height information also. There are two antennas here, one for the azimuth information, another is for the elevation. From elevation, you can get the height or range into the sine theta, that is elevation, will give the range of the particular target. Okay, again the same thing used here. And when our troops go into the enemy territory or into the battlefield, they had to move along with their vehicles. There are so those troops have to be protected, and they move along with the tanks. They move along with the tanks on the border when war is taking place. Our people had to be protected. So the enemy will try to launch aircraft and drop bombs on our troops. Then we had to protect our troops from the aircraft. So this is one of the surface to air missile which tracks the aircraft and shoots down. It is the photograph is the Russian. We have, our India has procured them in large number. These are 4 things are there now. These are called the missiles. These are called the missile. This is a radar. This is a search radar, and this is a tracking radar. Okay, you will come to know about these things. Yesterday I have shown this photo. Synthetic aperture radar also use more resolution. How it is there, and this is the Indira radar made in India, and this is the smaller range radar, which is called the BLR, base smaller type of radars, which can give ranges of 100 to 150 kilometers. And this is the phased array radar, Akash radar, and which is being used for launching the Akash missiles, which is now protecting our borders, eastern borders. So here again, what do you mean by 3D? 3D means you should get, if you want any object in space, you have to give its location in 3 coordinates. That coordinates, what radar use, what you as a students, you must be knowing that there will be X, Y coordinate and Z coordinate. If somebody says X, Y, Z coordinate 3, 2, 5, you will be able to locate that particular point from the center point of that coordinate system. Radars use a different type of this system that is called the angular system. It will R theta phi. R theta phi. R is range. Theta is the azimuth angle. E phi is the elevation angle. So if you give R theta phi, then what happens is that you will be able to locate the object. You will be able to locate the object. That is the aircraft, where exactly it is flying. That is why it is called a 3-dimensional radar. 3-dimensional radar. But for your sake, normally missiles or space vehicles which go into the space will have 4 coordinates. One is R theta and time also. At what time it is there. What time it is there. And if you still ask me, more complex will be space vehicles will have n-dimensional coordinates. They are called Hankel algorithms. So whatever we are seeing is on Earth we are taking as a base. And when we talk about the coordinates, we talk only about the Earth being flat. But when we go from one planet to another planet, then the dimensions will increase. For example, in many of our missiles, it is not 3 dimensions. We talk about 6 dimensions, 6 direction of movement of radar. That is the movement of the object. When an aircraft is moving, it can roll, it can pitch, it can yaw. That means if it dips, there is a yaw. If it is goes sideways, pitch, roll, and yaw. These are the three rolling coordinates of the missile. This is not there for a aircraft radar. But when we talk about the missile guidance, we call it as a 6 dimension. Not only R theta phi, only roll, pitch, and yaw also we take into consideration. Let me not go into the details of how we design. So this is one of the very good radar. It is a French radar in which I got training for 1.5 years, and it has got a search radar here. I'm showing this search radar, and it can detect targets from 60 kilometers onwards. After it detects, it tells the tracking radar at what coordinates it is there. So the tracking, this will give an accuracy of 1 degree only in azimuth. It doesn't give the elevation. Okay, so these coordinates are given to this tracking radar, which we'll be learning in much more detail, and gives the accuracy of the location of the object or the aircraft, because if you see, if you go to Delhi, the aircrafts that will be landing or taking off will hardly have a 40 to 50 seconds gap at such a high speed of almost 250 to 300 kilometers per hour. Of course, when they go up to 800 kilometers per hour. If you make a mistake, they will collide. So how do you do exactly the location of those things? So this tracking radar comes into picture. The accuracies of this will be very, very high. Okay. Then just since it is the subject here, we should know also what is the history of this radar. If it is not that radar was there in 1800 year also, it is not there. Radar came into picture, is invented. It is an invention. Aircraft was not there in 1800 century. It was not there in 1700. It was recently in before the First World War, somewhere in 1900 BC, 1900 only, AD only. It is invented because of the necessity. For anything, necessity is the mother of invention. So how are these people fighting at that particular point in time? In 1914, before that, aircraft was invented. So military is the first person who uses started using this aircraft. Earlier days, people were fighting on ground with normal guns. These swords on horses, elephants, things like that. Once the aircraft was invented by the Wright brothers, aircrafts were used to go into the enemy territory, even though it is some hundreds of thousands of kilometers, then drop bombs in that particular territory and destroy whatever that particular country has got. Not only military installation, if you see the history of London, the 80% of the London, that is including the households, every house was destroyed by the Germans at that particular point in time. So how are they trying to find out the location of the aircrafts before this particular thing? Before World War II, locating was done by sound locators. Sound locators. If you see here, this man was trying to see, get prepared. If the aircraft strike is there, they will immediately give a siren so that people come out of their houses and go into underground silos so that their lives are protected. So through the binoculars, they used to get the information and give a particular zone, some interval for some kind of a time space interval for the people to come out and hide in concrete silos which are constructed underground. So these are binoculars. Then some people were using our music instruments. You see, this is something like a. It's what happens is in aircraft is going, the aircraft is flying. As you know, aircraft engines gives a lot of sound, unlike the normal vehicles, ground vehicles, they give a lot of sound. So when they give the sound at a distance, as the distance increases, the sound that is coming here reduces. So what they have done is, like our children use a convex lens to concentrate the sunshine and put it at a one location, so that the paper they put there gets heated up, things like that. Similarly, sound was captured from a larger area, and it is concentrated at one place. So they will know the arrival of aircrafts, bombers at a and use them some leverage time for taking action, like shooting down using the AAA guns, that is anti-aircraft ammunition guns. Okay, this we see. This is like our musical instruments for which we see in our marriages and functions like that. So here what happens is the person blows, but in this case the sound waves come here and get concentrated. All this gives some kind of a space leverage time for the people to know that bombers are coming within 15 to 20 minutes or something like that. So as we know that bomber is invented in 1914 when radar was not there. So before radar, they were using this kind of things for getting a time. Okay. Then this is a historical background of radar. I will not go into this. It is I have put here because many a times JNTU H asked question, give the historical background of invention of radar. Then you need to put down all these things. For that purpose, I have put it here. It is not that the principle of the radar was not there. People know that. People know when there is a communication taking place from point A to point B. When there is an object coming in between, there was a break. That means it is stopping or reflecting, giving the echo. So, but unfortunately, they were not concentrating at that particular point. This aspect can be used to locate or find out the radar. Once again, I want to tell you, radar was never invented for the sake of civilian purpose. Radar was mainly invented for the military purpose. After that only, the things came into civilian use. This present day radars, large number of radars came into civilian use. Similarly, like our mobile phones were not there earlier. The military only was using this walkie-talkies from conveying the information. So as time passed, the size became small and small. So that is how the military technology enters into the civilian life. The impetus for any research has come from only from the military R&D. The reason, one of the reason is this that we had to protect. There is a do or die situation. If our country is being occupied, you can see how much you people do not know. Our forefathers have undergone so much hardships, so much of hardship. Today you are able to live in comfort with all these items, convenient items our people were not having. So we had to protect the country's borders. Therefore, we need to spend a lot of money in military hardware development. New invention need to take place. Okay. Then as I told you, because this particular interference principle was put to use for another advantage. That is, not only you will know the presence of a object, target, but you can also find out the speed of the target. That was not possible with our eye. If a vehicle is moving at a particular, what speed you can say, even if the vehicle is very near to you, you can only say that the vehicle is moving very fast or very slow or medium speed. But can you be able to tell whether the vehicle is moving at 80 kilometers, 100 kilometers, 200 kilometers per hour? You will not be able to see, but CW radars will be able to see. What is the advantage of this? You will know later, because this principle is used our police people to catch us when we are going very fast. Yesterday I have talked about this earlier days when the surface to air missiles were not there. They were using this this is called AAA guns, anti-aircraft artillery. People, I do not know if some students have seen a picture called Guns of Navron. You see very beautiful picture, Guns of Navron. It is picturized in a very beautiful days, those days, even before the Second World War, how the First World War Germans were able to shoot down the aircrafts of the British people, and how this gun, what is called the gun of Navron, was destroyed by some of these mercenaries. Then only England could win the war over the German. Guns of Navron, very beautiful picture. It has been picturized in a very nice way those days. Guns of Navron. Okay, so this is the thing. Now let us go into the some fundamentals. I want you people to know what is a phase, properties of wave, phase, and amplitude. Suppose you have generated a sine wave. How do you generate a sine wave? Okay, electronically, yes, there is a signal generator you are generating, but a pure sine wave is generated by in your physics laboratory. You might have seen tuning forks. Tuning forks are the mechanical devices which generate the sound frequency. If you hammer it with a rubber hammer, they just vibrate and they give a different frequency. That's called the pitch. So in the physics laboratory, they tell you if the frequency increases, how we are able, our ear is able to distinguish between those frequencies. So if you plot this particular wave, similarly, we can generate this waves electronically also. What does it mean? The x-axis here is the time, the y-axis is the voltage. When it starts from here, it is 0. When it goes to the maximum, it's called the peak. So from here to here, it is one cycle. That is, from here to here, it is one cycle. That is, again, it is starting. It's called the amplitude. Suppose there is another wave generated parallelly, another signal generator, and both of them we put it to an oscilloscope with the same frequency. Then let us say that these two waves, it is impossible to synchronize them unless you take some other measures. So there is a difference here. This is called the phase. This is called the phase. It's called the 90 degrees phase. It's called the 90 degrees phase offset. So when we write this equation, because we will be dealing with this a lot of some kind of a mathematics here, we write this particular sign as a sine theta. This we call it a sine theta minus 90 degrees. This only you people know. Also, there is what is called electromagnetic polarization. Polarization is, if you see this maroon color wave, if you see in X, Y, Z, it is going in this vertical fashion like this. This is called the electric field. In 90 degrees to this, we have what is called the magnetic field. We got the magnetic field. Electric field, if it is there, there's a magnetic field. So therefore, these are at 90 degrees. Similarly, in radar, if you are generating a particular frequency and sending in this particular fashion, it's called a vertical polarization. That means y-axis, it is increasing the amplitude. Similarly, if you have got in x-axis, if it is amplitude is changing and y-axis amplitude is 0, then it is called the horizontal polarization. Okay. Then I am also giving some of these things. What is 10 to the power of 1, 100, 10 to the power of 2, 1000. How do you write this? So these things are written down. 10 is written down 10 to the power of 1, 100 is written 10 to the power of 2. Normally in radar, we don't talk about this 100, 1000, 10,000 like this. We talk what is called dB. The dB came into picture because we compare this with a standard. That is what is called coming to dB. A comparison is made. So how do you get this comparison? So suppose there is a signal. When we talk about the signal, pure signal, if it is somebody is making noise, the noise will get added up to that particular thing. So when we talk about that, we can always say it's a ratio, but we don't talk about the ratios in radars or microwaves. We talk about only the comparison. That is how much it is more than or less than a particular value. That is, for that we use this particular formula: 10 log to the base 10 divided by signal power by noise power. In this particular case, you can even use the standard things also are there. So if you say 0 dB, it's the factor is 1. If you said minus 10 dB, 1 by 10, it's minus 20, 1 by 100. If it is 3 dB, factor of 2, minus 3 dB, factor of 2. Okay. So then we talk about this antennas. One is called the isotropic antenna. See, most when we see our these towers, which are microwave towers, which even the mobile towers which we have in our colonies, they have got this particular structure. So this particular structure, when it is emanating, communication signal is emanating, it goes all around. This is called the isotropic antenna. Isotropic. It goes in this direction, this direction, this direction, this direction. 0 to 360 degrees. Not only that, it will also go from 0 degrees elevation to almost to the 90 degrees elevation. That kind of antenna is called the isotropic antenna. This isotropic antenna is required because the tower doesn't know where your mobile is located. It has to send the signal. So you need a isotropic. But whereas a directional antenna, with this kind of a antenna, you will not be able to get hundreds of kilometers of range. Maximum is, let us say, 20 kilometers or whatever is there with this kind of a thing. If your mobile is somewhere 50 kilometers, you will not be able to pick or send the information. But whereas the radar antenna is to look into objects, aircrafts which are coming from hundreds of kilometers, we need to increase the power in this this particular transmission. How do you use it? You use a parabolic antenna here. This is called the directional antenna. If you see our children also, they use this. When you see a battery here, normal touch cell. Behind that there is a convex reflector there. The whole energy, light energy, is concentrated in one direction. That's the principle of our torch sensor. Similarly, this directional antenna is meant to increase the power in only wind direction. Then you may say, if the target is somewhere here, how does it reflect? What is done is, this particular antenna is rotated mechanically. If it is rotated mechanically, it will cover all the 360 degrees. By doing this kind of a technique, using a parabolic dish antenna, you are going to increase the antenna gain. Okay. Of course, the light speed is, some people get very much confused with this. What is the wavelength, what is the frequency, and what is the phase? I'll come to that at a later time when things are okay. So, unfortunately, today we are using this frequencies in air, in a very, 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 very extensive way. For example, your mobile cell towers are using, police are using, military people are using for communication. The meteorological people are using this for communication. If you use the same frequencies in air, what is going to happen? They are going to interfere. They are going to interfere, and you will not be able to transmit any meaningful information. For that, as the users kept on increasing, the countries faced the problem. What they did, they came together and they said, distribute these frequencies for various uses. You give certain band to the police, you give certain band to the railway people, you give certain band to the defense people, you give certain bands to the cell towers. Like this, then the radars also came into picture. So military radars wanted certain frequencies. So therefore, they gave certain frequencies. These frequencies are, the radars cannot use any frequency that is available. So they allotted these particular frequencies to each one of this group of radars. We will come to know about those frequencies you see here. All the frequencies starting from 10 hertz, 100 hertz, 1000 hertz, then this is 1000 hertz, then like that you keep on increasing in megahertz, like this, you know. Then some frequencies, these are called the radio waves, microwaves, then infrared waves, ultraviolet waves, X-rays. We see X-rays are especially used in medicine, hard X-rays, gamma rays. These are all there is a microwave oven is given certain frequency around 2.1 gigahertz. It is B. Nobody uses that particular frequency. There is FM radio here, 990 megahertz to 100 megahertz, 110 megahertz. FM radios are used. Then AM radios, they use 300 megahertz to approximately 500, 600 kilohertz, sorry, 300 kilohertz to 400 kilohertz. So these are all fixed by the organization, world organization. Like we have the WHO, we have this particular organization for this distributing these particular frequencies. Okay, I will take 2-3 minutes more, then stop this for today. And to easily identify these particular frequencies, they have divided these frequencies into VHF frequencies, that is very high frequencies, UHF frequencies, ultra high frequencies, L band frequencies, S band, C band, X band, like that. So if you say that this particular frequencies starting from 100 to somewhere 330 kilohertz, if you see here, this is the table they had given. They just for telling this particular instrument using L band, this particular radar using H band, this particular mobile is using in UHF. Like that, these are the frequency bands which they have allocated. There is nothing very serious about that, except that it is earmarked by the World Organization, the telecom organization, International Telecom Organization, ITO. So we will be following this. Our radars need to work in this particular frequency. Don't think 30 to 300 megahertz means all that frequency is given for such radar. Only a particular band is given. Similarly, not 1 to 2, all these frequencies are not given. That is 1000 megahertz is not given. Only a portion of it has been given there. Okay. So with this, I will stop here. Tomorrow, I will tell you why the radar was, what is the purpose, what made radar to be invented. So today, like COVID, a lot of people, lot of firms are trying to make this particular the vaccine. Similarly, those days in 1939 and 40, when Germans were totally occupied Poland, Germany, France, Holland, Antwerp, almost all Europe, only Britain was left over. Britain was supposed to be a strong country at that time. They were having control over India, China, so many Singapore, so many things. They're a very rich country. So they were also at the verge of defeat there. The German bombers were attacking the London and other British territory by sending hundreds of aircrafts and bombing them. So we need to somehow stop them. How do you stop them? The one way for stopping is to know their arrival at least half an hour before. If you know that their arrival half an hour before, by some means, then they can send their own aircrafts which can fly. Bombers will have, they cannot maneuver because they are carrying a lot of ammunition, but interceptors can maneuver. So they can maneuver and shoot down these bombers in air itself by using their guns. They are using their anti-aircraft guns that are located on their aircraft interceptors. So that 15-20 minutes was very crucial. So somebody should tell us. Today we are struggling every day. I'm praying God, when this COVID vaccine will come, when this COVID, it may be same for every one of us, one of you. So once vaccine come, we can take the vaccine and go. Similarly, once you know that an aircraft, German aircrafts are coming 15-20 minutes back, it's easy to shoot down all the bombers. So invention, something. So the British was using a lot of money, like what we are doing, all countries are doing, using, even Americans were using a lot of R&D money to find out this particular device which can give advanced information about the incoming bombers. So that is where that is the necessity, dire necessity was there. So in 1939, 1940, 41, the radar was invented, and the man hero is one person called Robert Watson Watt. That is why to honor him, we have one unit called Watt. You know what is the power unit. So he is the person who has rescued the second, the Germans defeated the German and rescued the whole world. You know what are the atrocities committed by the Germans at that point in time. They used to kill Jews in gas chambers, so many things. If you read history, you will know. Okay, so we will try to talk how these people are able to succeed and win the Second World War. So these are the heroes. Today, let us hope somebody will come out with the vaccine immediately, so that we will get relieved of this particular hardship we are facing. Similar was the situation in 1939-40 at that time by the British people, Americans, all those people. Okay, thank you very much. I'll conclude here. I'm sorry I exceeded 10 minutes. Okay, from tomorrow onwards, we will go into the early days of radar, how it is invented, how it is used, then go into the functionality, what are the fundamentals of radars. Okay, thank you very much. Any questions are there?
This conference is no longer being recorded.
Thank you, sir.
uh,
Participants, do you have any questions?
This
sir.
conference will now be recorded.
Yes, sir. Not
Please go
recording.
ahead.
Yeah, yes, sir. Not regarding the lecture, but for further reference, where can I find this recorded session, sir?
We will definitely share with you after the successful completion of this course in the WhatsApp group or at your mail. We will provide you.
Okay. Thank you, sir.
Welcome. Sir, another question from the participants is there in the chat box. Sir, what type of radar used to kill Mr. Osama bin Laden? Is radar used in cricket match? Thank you. Yes, sir.
hello? Can you please
Yes, sir. Yes,
repeat?
sir.
Can you repeat?
Sir, someone is asking what type of a radar used to kill Mr. Osama bin Laden. I
Oh,
think,
see,
sir, yes, sir.
much of how it has been, they are able to locate Osama bin Laden is still kept as a secret. But what is known from other quarters is that people in the Pakistan itself has given out the military people, somebody might have got the information where this particular person with his family is living, because not all the military people are knowing there. Maybe some people who want to sell this information to Americans for money, they would have given this particular information. And using this particular information, the satellites which are they have concentrated the satellites onto this particular area. That means these satellites will zoom on into that particular place. Who is coming, who is going, and what is the activity that is going on in this in that particular place is being monitored by the satellites. So today you have through the Google, you can even see your houses so very easily, because the satellites are able to tell us exactly the with a lot of resolutions. The Americans have got a very sophisticated radar instruments, optical devices, IR instruments located on the radars. Then they can even pinpoint a particular person. With that kind of a technology, they have made a lot of rehearsals before launching this, because it has to be perfectly managed. If they make some mistake, there will be a hue and cry from all the nations. So they have done it with a lot of precision, bringing them their helicopters. Those helicopters, very large helicopters. So it's all a very secret mission. It requires a lot of planning, meticulous planning, and also a lot of demos, rehearsals made on synthetic type of structures made. So therefore, they were able to succeed. That is the what maybe in the exact story of that, how they have done all these things may come out maybe after 5 to 6 years afterwards, because they don't want to reveal how they have done. Because if they reveal, people will come to know what is the equipment, what is the sophistication of the equipment they are possessing at that particular point in time. Then they can take a remedy. Somebody can take a remedy action. Okay, that's what.
Sir, sir, may I say something regarding
Yes,
this? Actually,
yes,
long
yes.
before I have read one article that
Okay.
radar having some blind speed range over there, they are not able to radar are not able to find that aircraft, particular aircraft. Americans are used that blind speed of range of the Pakistani radars, so they are make their aircraft hidden from them themselves to this operation.
Yeah, yeah. There is what is called passive radar. Passive
Yes, sir.
radar is a lot of this particular passive radars Chinese have invented. Chinese are the masters in this. See, what happens is in the case of a radar, you transmit something and you wait for the echo. Then once you transmit, there is what is called EW, electronic warfare. When you transmit, somebody can listen through the electronic equipment. If they listen, then they can make out by their location also. But in this passive radar, you don't transmit anything. Here, what is done is their surroundings. There may be lot of TV towers. Surroundings, there may be some military installations which maybe for everyday practice they may be transmitting into the air, or you may be having cell towers, that kind of a UHF, things like that. When they transmit, they give reflections. These passive radar receivers capture those echoes. That means they are not transmitting, but they actually they capture the echoes transmitted, echoed by the already friendly these people who are already transmitting. So by that they will be able to locate.
This conference will now be recorded.
So the more you dig, the more you get into that, and the interest. There's so many things which you do not know what has happened, and they may be revealed after some time in an accurate accuracy data. The reason they don't reveal now is that they don't want the people to know what type of equipment, what type of techniques, what type of technology they have used. Okay, that's what I want to say.
Okay, sir. Thank you, sir. I think next question is answered by already Surendra Reddy, sir. Now we don't have any questions, sir.
Okay,
So
we'll close. We'll close.
now with your permission, we can close this class. Tomorrow, please join at sharp 11 a.m. All the participants are requested to join tomorrow at sharp 11 a.m.
Sir Kumar Swamiro, sir. Thank you very much, sir. So I request all the participants to join tomorrow next session at 11 a.m. We will give you the link. Okay. So thank you so much. Thank you, sir. We are closing the session, sir, with your permission.
Okay.
Thank you, sir.
Thank you.
This conference is no longer being recorded.